بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will see the last video concerning probability, and we will see the probability tree. Now let's see another example. A tourist agency offers its customers two choices of 7-day voyages, full board or half board. The agency estimates that 25% of the customers choose France, 35% choose Italy, and others choose Turkey, and that out of its customers to any destination, 60% choose full board. So 25% of the customers go to France, 35% go to Italy, and others go to Turkey, which are 40%. And to any destination, whether we are going to go to France, Italy, or Turkey, the probability of choosing full board is 60%. Now, in order to translate this given into a tree, let's begin. We can say that we have France, Italy, Turkey. France is 25, Italy is 35, consequently Turkey is 40. And to any destination, 60% choose full board, so 40% would choose half a board. So this is the tree that we will have. Well, one might ask, can we draw another tree? Let's see. If we use full board, half board, so this is 60 and this is 40. And we need to continue with France, Italy, Turkey. You see that in this case, we don't have the probability of choosing France, knowing that we've chosen full board. So in this case, we can see that the tree cannot be completed. That's why in case I cannot complete the tree, I try to flip the events. Now here we've chosen B bar, then FIT, so we flip them and we put FIT and then B bar, B bar. So here we cannot continue. Let's go back to the same given and the same story. Now, a customer is questioned at random, and from this A, which means that one item or one piece is selected, we can see that we can use the tree. Consider the following events. F means France, I, Italy, T, Turkey, and B means full board. The same letters that I've used before, and this is the tree. The question is to calculate the probability of B intersection F. Now here for B intersection F, this is B, this is F, it will be directly, easily, it will be 0.15, and the probability of B intersection I, we know everything, this is B, this is I, it will be 0.21, and the probability of B intersection T would be B and T, which is 0.6 times 0.4, which is 0.24. And finally, we need the probability of B. Well, to choose a full board, it could be full board and France plus full board and Italy plus full board and Turkey, which is 0.6, which is in fact given here as 60% choose full board. Now the questioned customer has chosen full board. What is the probability that he chose Italy? This is a conditional probability. This would be the probability that he chose Italy, which is the probability of I given he chose full board. Applying the property, it will be 7 over 20. Now let's see the last application. A and B are two jewelry shops that sell silver, gold, and diamond pieces each. So each shop sells silver, gold, and diamond pieces. We know that shop A sells 1/4 of the pieces. Now from here, if shop A sells 1/4, this means that shop A bar, which is B, sells 0.75 of the pieces. Now LAD comes and selects a piece of a jewelry. Again, LAD means one piece or one item, so we can use the tree. We know that the probability of selecting a silver piece, given that it's selected from shop A, is 0.3. So let's translate this verbal expression into a probability and then put it on the tree. This means that P of S given A is 0.3. So we come here to A and we put S, and its probability would be 0.3. Now, the probability of selecting a golden piece knowing that it's selected from shop A is 0.6. Also, if we translate it, we get the probability of a G given A, and this is put here on the tree as 0.6. And we can tell from here that for diamond, if this is 0.3 and this is 0.6, this would be 0.1 because the sum is 1. Now the probability of selecting a silver piece is 0.225. Now we cannot see it directly on the tree, so let's leave it alone. And the probability of selecting a diamond piece from shop A is 0.09. This means D intersection B. We cannot also see it directly on the tree, so we leave it alone. So far, we still have P of S and P of D intersection B. We couldn't put them on the tree. Now, we have to fill in the tree with S, G, D when possible. Well, leave them and try to see how does the question work and try to answer each question alone. Determine the probability of selecting a silver piece from shop A. Remember, this is not a conditional probability because we don't have knowing that and given that and the terminologies that are used in conditional probability. Well, here we need the probability of S intersection A, and we can tell S intersection A from the tree, which is 0.3 times 0.25. Now determine the probability of selecting a diamond piece from shop A. Similarly, this is D intersection A, and we can tell it from the tree. Now prove that the probability of selecting a diamond piece given that it's selected from shop B. So this is a conditional probability. Let's begin working. This is the probability of selecting a diamond piece given that it's from shop B. This is the probability of D given B, which is D intersection B over P of B, and we know D intersection B from before, so it will be 0.12. And from here, if this is D given B, we can come to the tree and we put it here. This is D given B. We can state that this probability is 0.12. Now determine the probability of selecting a silver piece from shop B. So this is the probability of S intersection B. We don't know it from the tree. Let's see what's happening. Now what is S intersection B? It's the probability of S minus the probability of S intersection A. I know S intersection A. It would be 0.15. And we cannot put it on the tree because the tree doesn't contain intersections. Now the selected piece is from shop B. Prove that the probability of selecting a silver piece is 0.2. This is a conditional probability. We need the probability of S given B, which is the probability of S intersection B over P of B. We know the probability of S intersection B from part 4, which is 0.15, and we know P of B, which is 0.75 from the tree, and this would be 0.2. And by now, what is P of S given B? We can put it on the tree also to get 0.2. And if this is 0.2 and this is 0.12, this would be 0.68. Now prove that the probability of selecting a golden piece is 0.66. Now what is the probability of choosing a golden piece? It will be golden from A or golden from B, which is the rule of total probability, and we can take it by now from the tree. From the completed tree, we get 0.6 times 0.25 plus 0.68 times 0.75, which is 0.66.